So friends, very good evening to all of you, and I really welcome you to this today's session. And friends, this is the participants workshop.
I'm not able to hear anything.
Hello. This is your workshop, and you are here to participate in this particular workshop. And I want your active participation in it. Saloni, if somebody is unmuting himself or herself in between, just mute that person.
Yes, sir. Sir, I'll mute everything. Yes, sir.
Then Jayanti is there. Who is that? Jayanti Pal. Who is that? Yes.
Sir, all participants are requested to mute themselves and turn their cameras off. If there's any, otherwise I'll have to mute everybody at once. Just to make this interactive, we've allowed all participants to unmute, but please, if there's any kind of disturbance, then we'll have to mute everybody. Yes, sir, you may please carry on.
Are you able to hear me clearly, or is my voice is low, or what?
Sir, otherwise it's clear, but the pitch is a little low.
Okay, so I will pitch it higher, right?
Yes.
Okay. So I was saying that it's your workshop, and you have to participate in this particular workshop. You have to start fresh, and during the whole workshop, you have to train hard yourself. And in the end of the workshop, you feel proud that yes, you've really learned something out of this particular workshop. Friends, never forget these words of Steve Jobs, who said that the only way to do great work is to love what you do. The fact you people have joined this particular workshop shows your love for learning. And if you love learning, you can do wonderful things. And learning is something, which makes everyone highly satisfied. Let's start our session for physics with a lot of positive energy and with a lot of yours love and affection. So friends, your cooperation will be highly appreciated. As I said, it's your workshop, and we are here to learn the things. Whatever little doubts you have, whatever queries you have, please don't hesitate. You can put your queries either in the chat box or you can ask me directly, but make sure whatever we are discussing, whatever we are trying to learn, we are really learning that particular thing, and that too with understanding. So I believe all of you are ready for this session, and let's start and welcome you again to the session. And two things we have to talk about. One is ANOVA, another is MANOVA. But let's begin with a very important thought, which I really love. It says, if you cannot explain simply, you don't understand it well enough. If you have really understood something, you can easily explain it. You can explain it in simple words. If you do not understand something, it will be very difficult for you to make understandable the other person. Understanding is very, very important. If you understand, you can explain it simply. And if you don't understand, you cannot explain it. And many of you, I believe, are the teachers, and they must have experienced this particular thing. Whatever thing you are very confident and you understand it, the kind of the delivery you have for that particular topic in the class, I tell you that's completely unmatched. The kind of the satisfaction, the joy which you get when you explain something which you really understand, that's totally unmatched. So whatever you are trying to learn with understanding. That's very, very important. And today, whatever we are going to learn it with complete understanding. And in that process, if you have any query, I'm again requesting you, don't hesitate in asking questions. Anytime you can throw your questions either in the chat box or you can unmute yourself and talk to me directly. But do make sure that you understand the things and there is no confusion, no queries, nothing in your mind, absolute clarity in your mind. So with this, let's start our today's agenda. That's analysis of variance or ANOVA. It says something to share with you. Do you know? Talking to you makes me smile and makes my day. And that's one of the greatest award to a teacher. When a teacher speaks to the students, a teacher speaks to the participants, the kind of the satisfaction he gets out of their energy, out of their smiling faces, that really makes our day. So let's have a look at a news item. It says use of plastic bags is banned. Center bans plastic bags below 50 microns. And this news item is creating opportunities and also maybe threat for sample. And some people may be getting some business sense out of this particular news item. Managing director of a paper mill sees a business opportunity in it. Start manufacturing paper to be used for making paper-based grocery bags. So if there is a ban on the plastic, then the demand for the plastic bags will be reduced and the demand for the substitute, and one of the important substitute is paper bags. And to produce paper bags, you need hard paper, and to increase that strength of the paper, the manufacturing paper mill has to do something about it. So what they think that they say that if you add hardwood concentration in the paper pulp, we can increase the strength of the paper. And they are experimenting with 5% hardwood concentration, 10%, 15%, 20%, and seeing the impact on the strength of the paper. And the strength of the paper, PSI, is called the tensile strength of the paper. And for each combination, 6 runs are being done. And accordingly, the strength of the paper is recorded. Okay, this shows what to do with this data. Data is being collected and what to do with this data. Anybody suggest what we can do with this data? You have data in your hand, what you can do with this data. Shalini, can you tell me what we can do with this data? What is that we would like to infer out of it? Shalini, are you there? Anybody else?
Yes, sir, I was unable.
Hello, anybody else?
We can plot it to see the trend line.
There is no trend. Trend is a function of time. There is no timeline. So we cannot come out with the trend. Think. You are because you think. Anybody else?
Sir, we
Yes,
can,
Shifa.
sir, this is Sahifa. So we can see whether this strength is same in every round, as there are every run as there are 6 runs. Whether the
You
strength
say
is
whether you have 5% concentration, 10%, 15%, 20%, the mean strength is same. Is that you're trying to say?
yes, sir. Whether mean strength is same in every round for these different hardwood concentration.
Okay. Why do you think they will be different?
By chance.
It's by chance or it's by design?
I mean, in 5%, when we take hardwood concentration 5%, in first, second, third, fourth, fifth, sixth round, it will be different by chance. It can be.
Is it by experiment or is it by chance? The difference which you will find here, what do you think? Is it by chance or by some experimental design?
No, sir, I'm not saying difference between 5% and 10%. I'm saying difference in between the runs, the different first,
So
second.
you mean to say the difference between 7, 8,
Yes.
15,
Yes.
that's by chance.
That can be by chance.
Okay. In statistics, we don't use the terminology by chance. We say this may be random, right?
Yes. Yes, sir, random.
But why there is a difference? Yes, sir. Think. Don't you think that we are trying to see is the change in hardwood concentration has impact on the tensile strength? Can I say that strength is a function of hardwood concentration? Can I say this?
Yes, sir.
Yes, sir.
So what does it mean? I'm trying to study a causal relation, right?
Yes, sir.
So if you want to study a causal relationship, then how do we do it? That's a challenge. Let me take another example. Okay. So we have the impact of different methods of killing bacteria in the hands, and we get this means. सलोनी ये बैकग्राउंड नॉइज कहाँ से आ रही है?
सर मैं अभी चेक करती हूँ, एक सेकंड.
Okay. So if you are trying to test whether the means of all this is same or not, then also we are using ANOVA. So I have a question here. Are we using analysis of variance to check whether y is a function of x? Or to check whether the means are same? What actually we do in case of analysis of variance, that is something which we have to understand. Are we testing this? Are we testing this? Can you use analysis of variance for your causal research design, where you experiment and collect the cause and its effect and study the impact of the cause on the effect? Or are you trying to just look at the equality of the means? Or are the same?
Not the same.
Why do you say they're not same? Why do you say that they are not same?
The second one, we are testing the equality of means. First one,
Yes.
we are checking the whether it is the same model.
Right.
Why is
Right. Right. Dr. Maya, we will say it whether they are same or not as you proceed further. Besides testing quality of means, we can look at the ANOVA from a different perspective as a tool for establishing causal relationship where X is causing Y. Do you know any other tool that helps you in establishing causal relation between X and Y? Any other tool? Hello?
Regression, sir.
Yes. Sanish, right?
Yes, sir.
When I use regression, what kind of Y you should have? Nominal, ordinal, scale. What kind of X we should have? Again, nominal, ordinal, scale. Anyone? When you do regression analysis, what kind of data you have for X and for Y? Will give me the answer. Quick.
So for Y, we should have scale data.
We should have scale data.
Scale data.
For both or for X or Y?
For both regression.
Okay. But if X is not scale data, if X is nominal data,
then I know significance difference between the two.
Right. So when your X is not a scale data, it's a categorical data, there you have to make use of analysis of variance. So are you looking at motivation in the function of the plants? Your different plants of a company are located at different places. Do you think all the people are having same level of motivation across different plants of a company? Motivation is my dependent variable, plants is my independent variable. This is my categorical variable. and this is my scale. Is sales which you have in a department or store depends upon the way the products are being displayed. This is your dependent. Sales is your dependent, display type independent, sales is ratio, scale, and independent is categorical. For this kind of problem, we can make use of analysis of variance. Okay, so get clarity. I'm using analysis of variance where my y, which is dependent variable, is a scale level variable. And x, which is my independent variable, it's my categorical variable. Okay. Dr. Maya, I have a question. You have plant 1, 2. Let me take 2. We collected the motivation level of the workers working in plant 1 and 2. Look at their means. Why their means are different? बाद में call करूंगा मैं. Why their means are different?
They are different samples.
So, on what basis we are taking different samples? Okay, let me take more simple example. We have a gender, right? So we have taken male students and female students. Passing marks in schools, class 12 for male, for female. I get the mean marks of the male students, mean marks of the female students. Why they are different? Suppose they are different, then why they are different? Of course, I have taken 2 samples, sample of male and sample of female. But why their means are different?
They must have scored different marks. They must have scored different marks. All the respondents have scored different marks. It's a variable.
But why their marks are different?
The first thing is for different samples and
different sample is based on the gender, right?
Yes, sir.
So you have male and you have female. You got the mean of it. You got the mean of it. Yes. What is that which causing this difference?
Because sir, it's a mark. So marks depends on many factors. And even for male, the factor may be different, like intelligence level and other things. And for female, again, that will be different. Even though we take that into that one for male and female, because independent samples are there, so it cannot be same.
Okay. May I know your name? Because your name is not reflected here.
Samir Sarkar.
Samir. Samir ji, the marks which you have here, the difference in the marks, we don't have any information about other factors. So I'm assuming they're constant. What is different in the gender? Don't you think the gender is causing difference in marks? If their means are different, what does it mean? It is the gender which is causing the difference in the marks. So I can say the marks is the function of gender. Okay, let me take again a consumer sample. Consumers from rural background, semi-urban, urban. And we are studying their expenditure on branded products. So I get the mean here, mean here, mean here. Why they are different? If they are different, why they are different?
These respondents are from different area.
Because it is the background of the consumers which is causing this difference. So can I say that expenditure of branded product? Can we ask Janti Pal to
लेकिन सबको ही म्यूट कर दी क्योंकि इसको
सलोनी तुम सबको म्यूट किया क्या?
हाँ जी सर, मैं सबको कर रही हूँ, फिर आपको अनम्यूट कर दूंगी।
मुझे अनम्यूट कर दोगे मैं?
जी सर, कर दिया।
सलोनी एक जने
जी
की
सर,
पनिशमेंट
जी सर,
सबको
हो
मत
गया।
दो। एक जने की पनिशमेंट सबको मत दो। अगर जयंती कुछ गलत कर रही है तो उसकी वजह से सब लोग को क्यों सफर करे?
जी सर, मैं कर देती हूँ चेंज।
हाँ, जयंती को म्यूट कर दिया करो ना तुम।
हाँ जी।
Yes, Anjali, do you want to say something? Anjali, Anjali, you have raised hands.
शायद से गलती से हो गया, मैं एक मिनट। अच्छा, मैम को शायद अनम्यूट। हाँ जी,
ठीक है, ठीक है। So the friends, the point which I'm trying to say is, if you look for causal relationship between X and Y, and you test for equality of the means, they are one and the same thing. Dr. Maya, it's not different, they are same.
Yes, I understood, sir. I understood.
Thank you.
Thank you, sir. Thank you, sir.
Analysis of variance is applied when one has more than one samples under a study coming from different populations or same population with different treatments. Okay, I believe that ANOVA is not a new term for all of you. Can I use ANOVA for two samples?
No, it has to be a t-test.
But can I use ANOVA there? You're right.
Yes, ANOVA can be used.
Yes,
ANOVA can also be used.
Yes, Vikram, please go ahead. Mr. Vikram?
Yes, ANOVA can also be used.
Yes, because many people say that you cannot use ANOVA for the two sample. For two sample, you have to use t-test, but that's not, necessary. Any number of samples, provided more than one, if you have, you can make use of ANOVA. But T can be used only for two samples. ANOVA is more generalized framework as compared to T. Analysis of variance is a hypothesis testing procedure used to determine whether mean differences exist between two or more samples or treatment. Analysis of variance many times creates confusion in the mind of the people. People believe that it's a testing about variances. No, It's not testing about variances. It's testing about means. We're testing about means.
Hello.
Yes.
Sir, why is it so that only change of one sample uh, force us to use another technique? We have 3 samples, then we have to use ANOVA. We have 2 samples.
Altaf, can you say again what you said?
So, if there are 2 samples, we use t-test.
Right.
But there ANOVA can also be applied.
Yes.
Uh, when there is change of only one sample, that is, it is 2 to 3, then we do not use t-test. Instead, we use ANOVA. Why
Right.
is it so, sir? So, sir,
Because
just change of one sample.
T is only applicable for 2 samples.
Yes, sir.
And ANOVA is more generalized and it can be used for 2, 3, 4, 5, 6, 7, 8, like that. It's not a question of one, it's a question of more than 2. It's a question of more than 2. What we do in t-test, x minus mean upon standard error. So you can use only one variable here. And in a t-test, we use difference. So we use here difference between 2 samples. So T is not meant for more than 2. Therefore, anytime you exceed 2, you have to use ANOVA.
Okay, sir. Thank you.
Okay, Sharmila is asking, what is the concept of different samples? Okay, so different samples means okay, I think we have to understand it. Suppose we are doing a market survey. And we get sample of say 700 respondents. So if you look at from that perspective, you got one sample of 700 people. But for analysis purpose, what we do, we divide it into different subgroups depending upon their particular characteristic. And that subgroup I'm calling as a sample. You can group them in terms of male, in terms of female. You can group them in terms of young, middle age, old age. So if you group on the basis of male, I will say you have 2 samples. Sample 1 for male, sample 2 for female. If you do it on the basis of this, you are having 3 samples. 1 sample of the young people, 1 sample of the middle-aged people, 1 sample of the old age. So in that sense, I'm using the terminology 2 samples, 3 samples, and 4 samples. Yes, Dr. Shika, t-test is the significant difference between means of the 2 groups. Yes. You call it group, you call it samples. I don't make much difference between them. Anybody else having any other question? So what I'm saying is that we have to test means. And we test this mean through variances. So we study variances of the sample. And through those variances, we will try to check equality of the means. How do we do it? That's what we have to understand. So the term analysis of variance appears to be a misnomer, and the objective is to analyze differences among means of the samples rather than variances of the samples. If we assume that all samples are coming from the same population or the treatment across has no effect, then the variation among the means and the variation across the group will be due only because of sampling error or because of the randomness of the data which we have collected. If it is so, then the variation within group and the variation among the group should be same. And this is what we do in case of analysis of variance. The total variance is divided into two parts, within and among. And then if within and among are same, that means treatment has no impact. If they are not same, then we say treatment has an impact. So what I mean by this, let's take an example of it. I think let me take that example, right? 5% hardwood concentration, 10% hardwood concentration, 15% hardwood concentration, and 20% hardwood concentration. So we get different observations here, 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 here. We have also seen that all observations are not exactly identical in each group, they are different. So you have variations within. And why this variation there within, I don't know. Maybe because of some other factors which we are not able to control, whatever it is. I do not know why same concentration of hardwood is giving me different strength of the paper. I don't know. But within variation does exist. We all know that. You can take any example, say, rural background of the people, consumers, semi-urban, urban, metropolitan. Within each group, you will find variation. And that variation may be because of something else. Okay, we got the means here. 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 Okay. They are also different. They are not identical. They are not same. This variation which you see is called variation between the groups or among the groups. That's among the group. This is within group. Okay, I make an assumption. Within group variation is same for all groups. Suppose I say standard deviation of 1, 2, 3, 4. If I make an assumption that within variation is same, it's not different. Okay. And if I make a null hypothesis that means are same, then how do you see the relationship between among the variance and within the variance? How do we see the difference? How do we see the relation between within group variation and among group variation. Please appreciate these two assumptions, because null hypothesis say means are same. And we are assuming that variation within each group is same. Then so whatever variation you have within, that will be reflected here. Because concentration is not impacting my mean. Whatever variation same. Okay, and this is what exactly F does. Sorry, ANOVA does. ANOVA use F, which is a test of equality of the variances, variance among, variance within. If it is closer to 1, that means within and among they are same. That means grouping has no impact. And if grouping has no impact, then means are same. That's the basic idea and the basic philosophy of analysis of variance. I hope you are able to visualize what I'm trying to say. If you have any doubt, any question, you please let me know. But make sure that you get clarity about the things. Don't afraid. Don't hesitate.
Sir, the variance among the...
Yes, Sanjay.
Yes, sir. Sir, I'm asking that the variance among the groups will be there due to the concentration is different?
Yes, so that means concentration has an impact.
Yes, sir.
That means I have to reject my null hypothesis. They're not same. Then I can say concentration is causing differences in the means of the samples. Is that clear, Mr. Sanjay?
Yes, sir.
Okay. Anybody else? So when the observations are subject to experiment related to factor 1, we say one-way analysis of variance. And if there are two factors causing, your impact on your dependent variable, then we have two-way. Like that, you can have three-way, four-way, five-way, and so on. What does it mean? Now, say for example, consumer loyalty towards brands. If I say it's a function of gender, age, then I'm considering two factors, then my analysis will be two-way analysis. Two-way analysis of variance. If I add one more factor into it, background of the consumer, then you will have three-way analysis of variance. But today we will concentrate on one way. If differences are found to be significant, then it could be concluded that differences are due to the treatment of that particular factor. ANOVA divides the total variation into two groups, among and within. And null hypothesis is all means are same. What will be the alternative hypothesis? If you say mean 1 is equal to mean 2 is equal to mean 3, and so on. That's my null hypothesis. What will be my alternative hypothesis? Anybody?
H1 mu1 not equal to mu2 not equal to.
So it will be not less than, maybe greater than or less than.
Maya, Samir, alternative will be at least 2 of them are different.
Okay,
Doesn't
sir.
mean that all are not equal.
Yes,
It doesn't
yes,
mean
sir.
any 2 of them are not equal. If you have mu1 not equal to mu2, but it may be equal to mu3. Mu1 may be equal to mu2, may not be equal to mu3. So at least 2 of them should be different. Not all should be different. It's not that. So alternative hypothesis is at least 2 means are different.
Yes, sir.
And F, we know that F is a statistic which is used for testing equality of the variation between the groups or among the groups and within the groups. And it's a test of equality among the means and not that of the variances. Its null is all means are equal, alternative is at least 2 means are different. And it makes assumptions about the population. Variances are same. All variables which are dependent variables, why? They are scale level variable, and we are also assuming normality assumption. And because of these assumptions about population, analysis of variance is a parametric test. Okay. Before I take an example and do it in SPSS, any one of you have any doubt about analysis of variance? What it does? Why do we use it? Where we use it? If we make groups, you can call subgroups. We have population, and we are making groups on the basis of some criteria. Then we want to check whether the means of these subgroups are same or different. If they're different, that means the criteria which we are using is impacting the difference. And what it does, it calculates variance within, variance across, use F to test whether the variance among the group and variance within the group are same. And that's how it works. Okay, is that clear? Let's take an example and see. Yes. Yes, anybody? Okay.
So can you again tell me that one-way ANOVA?
One-way ANOVA means it's a relation.
So only one independent.
Yes. one independent variable.
Okay.
Samir, give me an
And 2m is two independent variables.
where you have causal relationship between scale level variable and categorical variable. Any example, any area. Do you think the ROE of a company, return on equity of a company, is a function of size? Big firms, small firms?
Yes.
Is it a function of age? Old companies, new companies?
Yes.
That means two-factor, two-way analysis. Third, ownership. Private, public. Then you will have three-way analysis.
Three-way.
The number of factors you go on increasing, the analysis become more and more complex. But the philosophy is same, the idea is same. Okay?
Yes.
Anything else?
No, sir. Thank you.
Okay. An experiment was conducted to understand recall mechanism among the people. 50 people were selected and they were randomly assigned into 5 groups. 4 are these. 1 is intentional learning group. Each group was given a list of 27 words and each one was asked to read them and recall. And data was collected. So number of words recalled as a function of level of your counting, rhyming, adjective, imagery, intentional, and that the data which we get. What is here we would like to check? Recall is a function of learning, or mean recall of, say, adjective is equal to mean recall of rhyming, imaging are the same or not. And that takes us to ANOVA. Let's see how do we do it in SPSS. So I go to Saloni, just ask Anjali whether they have shared the files with the participants.
Sir, all the files have been shared already.
Okay. So participants, if you wish, you can do it along with me. Give me a minute so that I can open my SPSS and open the file. In the meantime, if any one of you have any query, please let me know. Please don't hesitate in asking questions. If you really think you need something, you can ask me.
Can you sum up whatever you have told? I mean, what I have understood is that by analyzing the variance, by analyzing the means of more than 3 groups, we can conclude about their variances. Is it so?
No, no, no. Reverse. By analyzing the variances, we can conclude about mean.
Okay, thank you.
That's why it is called analysis of variance. Analyze variance, and from that you get the inference about the quality of the means. Vikram, you are from which place?
I'm in JNU.
Okay.
So one more question. Is there a lot of difference between SPSS 25 version and 27 version?
Mostly interface and the graphics. Otherwise, the basic procedures are same. The difference is only the way you get the output. So the output is structure, the table is structure, that's altogether different. I just open a file. This is my data. If you want to see the graph, you can make the graph chart below. And suppose if I make a box plot, then x-axis I'm taking here, number of recall here. And you will see that the box plot we got here, which is like this. Anyway, so let's go to analyze and compare means one way ANOVA. My dependent variable is number of recall and the factor is level of this. Okay. And that's my result. I open a file. You may not be able to see it properly. So what I'm doing is I'm copying it from here, pasting the word. There we can see it. Less than 5%, null is rejected. There are differences. So we have 5 levels of learning. So my question is, if there is a difference, where the difference? It's not necessary that, I get every one different from other one. It may be possible that some are different, some are not different. To know that, we perform what is called post hoc analysis. So I go to ANOVA again. And post hoc. And widely used one is Tukey is a statistical tool that can help you in pairwise comparison. In options, if you want to see the graph, you can make the graph of the means. If I copy from here, you can see here, this is different, this is different, this is different. That means counting is different from adjective, imagery, and intentional, but it is not difference from rhyming. Star means significantly different. So rhyming is also different from adjective, imagery, intentional. Adjective is different from counting and rhyming, but not different from imagery and intentional. So by performing post hoc analysis, you can have pairwise comparison. Post hoc. You can have pairwise comparison, and you can know from there which one is different, which one is not different. Same thing you can see from the graph. Just if you see the graph, you can also find out counting and rhyming are almost same. Adjective, imagery, intentional, they are almost same. And Tukey also gives you the, grouping, which one are similar, which one are not similar. That grouping can also be seen there. If I copy from here, paste here. Now you can see this makes one group, they are similar, and this one is making another group. Okay, another thing which you'll find here is the maximum recall is here. So if you have to make a policy recommendation, what you will do? First, you will say learning level has an impact on the recall mechanism. If there is a choice, the best way is imagery, because that gives us the maximum recall level. So that's how you can suggest in, in your conclusion. that the box plot which we see, it also shows that they are almost similar. This group is similar. Does our story end here? The answer is no. Once we know that there is a difference, we must know where is the difference. Can you mute yourself? That's one group, that's another. Anything else we should do? Anything else we should do? What precautions we should use in case of parametric test? Anyone? What precautions I should use when we have parametric test?
To check the assumptions of parametric test.
Right, Shifa,
Equality of variance.
We have to check for assumptions. And you know the assumptions? Do you remember assumptions?
Normality,
Normality,
equality of
assumptions,
variance.
equality of
and
equality of variance.
Yes, normality and equality of variance. What is the test we use for normality?
Shapiro-Wilk and KS test.
Yes. SPSS is having KS test, Kolmogorov-Simonov test, and we have a number of tests for checking normality, but we will look at KS test. And for equality of the variance, we look for which test?
Sir, Levin's test of homogeneity.
Yes. Yes. Anybody?
Me, sir. Sir, there is some participants are facing a problem regarding the files that you have shared. Sir, can you please direct them ki how they have to go about those files?
These are SPSS files, so they can be opened only in SPSS. So if they're trying to open it through some other software, it is not possible.
Sir, I think, Altaf, that is what you were trying?
I was not trying with SPSS. I thought it is some HTML or Excel file. So, okay.
Yes, Manjari, you are right. Normality and Manjari, random sample we presume, it's not an assumption. Whatever statistical thing you are doing, it is presumed that your sample is being taken randomly. So that's not an assumption. Assumptions, Manjari, is to normality and equality of the variance. For equality of the variance, we have test of homogeneity, which is called variance test, and null assumption is, null hypothesis is variances are same. Alternatively, at least two of them are different. And here the significant value is more than 5%. So null is not rejected. So I show you how can you do that in SPSS. So you go to ANOVA, options, you have homogeneity of variance test. So when you are doing ANOVA by using SPSS, you go to options. In options, you will find homogeneity of variance test. Continue. Okay. And If you see here, we are testing based on variance 0.265, more than 5%, therefore equality of variance stands. So that assumption is not violated. Then another assumption is we have to check for normality. Normality check, that option is not available under ANOVA. You have to go to analyze, non-parametric test. If you do not have SPSS, doesn't matter, but at least you can note down these steps. For testing equality of variance, we use the 11 test that's available under the option of ANOVA. For checking normality, we use non-parametric test because KS test is non-parametric test. So we go to non-parametric test, legacy dialog, one sample KS test, number of recall, normal test distribution is normal. That's the output which we get. This is the test statistics. This is the significant value, which is more than 5%, and therefore null is not detected. That means distribution is a normal distribution. So my assumptions are true. So I need not to worry about it.
So can you repeat the steps of, I was writing the steps, KS test.
I shall do that.
Yes, sir.
So with another example. You have to check for the normality of the data, use KS test, and where that option is available, go to analyze, non-parametric test. In non-parametric test, go for legacy dialog. In that, you will find one sample case test. And for checking equality of the variances, we use the 11 test.
Sir, one question. This will give me same result as I do it through explore option in analyze, descriptive, and then explore.
Yes, same.
Okay, thank you.
Post hoc analysis to have a pairwise comparison, and you can also make a mean plot. So let's take another problem and see how do we do it. What is the impact of the different fertilizers on the production of wheat? That means I want to check the impact of the fertilizers on the wheat production. So it's a causal research, and wheat production is my dependent variable, which is scale level, and fertilizers types, categorical variable. So I can make use of analysis of variance here. So let's go to SPSS and do the practice for it. So let me open up a file, fertilizer. Analyze, compare means, one way ANOVA. Fertilizer type is my factor. Production of wheat is my dependent variable. I'm doing everything here post hoc. In options, I'm going for homogeneity of variance test and means plot.
Excuse me, sir. Sorry to interrupt in between, but
Yes,
can you please explain what is post hoc? I am unable to understand.
Once you find that the null is rejected, that means there is a difference.
Okay. Okay.
Where is the difference? If you say your null hypothesis that mean of 1 is equal to mean of 2 is equal to mean of 3 is equal to mean of 4, that is rejected, right? Now I want to know whether this is different, this is different, this is different, this is different, this is different. Where is the difference? Are they all different? Some of them are different, some of them are not different. How do I know it? So for that, we do what is called post hoc analysis. That's the advantage. Anjali, is that clear?
To know where it varies, right? To know mean.
Know where?
Like between the means where it varies, like they are not accepting the null hypothesis. Instead of that, alternate hypothesis is being.
Yes. So there is alternative hypothesis says there is a difference.
Yes.
So where is the difference? What means are different? That can be understood by doing post hoc analysis.
Thank you.
Okay. Shikha, you said independence, Dr. Shikha. I don't know what you mean by independence. Dr. Shikha, I don't know what you mean by independence.
Dr. Shikha?
I am copying from there and okay. So if you see this ANOVA table, (0.10), which is less than 5%. So null is rejected. What does it mean? There is a difference. Now the question is, where is that difference? To know where is that difference, you can look at the multiple comparison table. Look at where you see the star, that means that's a significant. Fertilizer 1 is significantly different from 3. 1 is not different from 2 and 4. 2 is not different from 1, 3, 4. 3 is different from 1. Only one thing we are getting here, and that is 1 and 3, they are not equal. All others are same. That's the only difference which we find. And if we see the homogeneity of the variance test, sorry. Variance is, they are equal, they are not different. And you can also check the equality. You can also check the, normality of the distribution. Prediction of test, my dependent variable. And if you see here, this is what we get here, not significant. That means distribution is a normal distribution.
पण आमच्या गाईडला एवढं काय ते
Okay.
ही वेगवेगळी university, ही दिल्ली
Sandra, could you please? So if there is a violation of adoption, then if you are having two categories of independent variable, then you can make use of Mann-Whitney test. Otherwise, you can make use of what is called Cruxell-Wallis test. And these are non-parametric tests, which are not based on any assumption. But use them only when you find the ANOVA assumptions are violated. So if I work with this problem, and this is my paper problem, just close it. And I go to analyze, compare means, one-way ANOVA. Tensile strength is my dependent. Hardwood concentration is my factor. First Chucky. Options, homogeneity of variance, mean plot. So homogeneity of variance is there, significant difference. Fifth is different from 10, 15, 20. 10 is different from 5 and 20. And that's the graph which we get. And if I check for normality of it, distribution is coming to be normal distribution. But let me, for illustrative purpose, suppose one of the assumptions of ANOVA is violated. So what should I do? We have 4 categories, 4 samples. So I should use non-parametric, legacy dialog, K independent samples is my this. Define group 1, 2, 4. I'm having 4 categories, 4 groups. So 1, 2, 4. Cruxell-Wallis test. and you'll find less than 1%, that means rejected. Okay. So hardwood concentration is a function of tensile strength. That's what we are looking at. And we have tested it. Now, how do you feel about analysis of variance? I think now you will be feeling comfortable with it.
Sir, I have a question.
Yes, Shefa.
Sir, my question is, if equality of variance is not assumed, then which post hoc test that we should go for?
No, in that case, you cannot apply ANOVA.
Sir, I'm talking about equality of variance because when in SPSS window, I saw two sections. Two case method was there and
that's a different question. When your ANOVA is not giving you equality of the variance,
okay.
One of the assumption of ANOVA is what? Equality of the variance.
Okay.
The assumption is violated. So my suggestion is go for non-parametric. So it gives me the option when I go for
yes, sir.
one-way analysis of variance post hoc, equal variance is not assumed.
Right,
then
sir.
it gives me like this. But this is when I'm doing pairwise comparison. So if I show you what does it mean. Just give me a minute. I go to analyze, compare means, independent samples, and I take only two group 1 and 2. I'm not taking all group, I'm taking only two groups. And I copy this. Now, to perform the t-test, you know what it does? See here. It assume equal variance or assumed variances are not equal. Equal variances are assumed and equal variances are not assumed. The pairwise comparison is based on T. And when you perform two sample t-test, there also we need assumption whether the variances are same or not. So the post hoc analysis is related to the equality of the variances between two pairs, not overall equality of the variance.
So in that case, we have to go for non-parametric test.
Yes, non-parametric.
Sir, I have 2-3 more questions. If you allow me, I can quickly ask them.
Why do you say allow me? It's your workshop. आप लोगों की workshop
है. Sir, a normality of data, we have to check group wise. Even if in a single group, data is not
overall, not group wise.
So if I have 4 groups, level 1, 2, 3, 4, for ANOVA, it is not needed that, for example, in group 3, data is not normally distributed. Still, I can go ahead with ANOVA?
Yes, overall thing. We look at the overall data, overall normality.
Okay. And sir, there is something effect size I saw on your screen in ANOVA. If you can explain about that.
Yes. It is similar to R square. What is R square?
Strength.
What is R square?
R square, variance.
R square. Anybody?
R square is goodness of fit, sir.
Yes. What does it show? Explain. Explained variance divided by total variation, right? What is R square? It is percent explained variance. The effect size is this. That means that particular factor which we are considering, how much variation it can explain between the groups. So I think let me pick up. Right. Sorry. Let me forget about this. Yes. What is my total variance? What is my total variance? This is my total sum of square. Between the group, so much. So 254.4 over 1. That's your R square. So I think it's approximately 50%. And if I show you here, if I take this up, can any one of you calculate 671 upon 9,899? How much is it? Six 71 upon 990. 899. Anyone? Can any one of you give me this figure?
Sir, approximately 74%.
0.74.
So this is what it says. This much. That means this hardwood concentration variable is explaining about 74 or approximately 75% variation in the strength of the paper. So that is what is called effect size. So we normally use eta square, which is nothing but your R square.
So do we get this by default in SPSS, or do we need to select any option to get the effect size in SPSS when we perform?
In case of, I'm using the latest version, so it gives you by default, but other versions you have to select the effect, size effect.
And is there any standard for this? It has to be above 50%, 60% while reporting?
More it is, better it is.
Okay. Thank you, sir.
Anything else? No? So that's all about ANOVA I want to discuss with you, and I'm getting no questions. So friends, let's take a time to break.
Yes.
10 minutes break, and after 10 minutes, we'll come back.
all participants are requested to please keep themselves logged in only. We'll be continuing with the same link in 10 minutes.
So friends, let's move next in our journey. It's time to think. And do you think that profitability, leverage, corporate governance, value of a firm, are they correlated? And why they are correlated? Indrajit, batao, why they are correlated? First of all, are they correlated or not? Do you see a connect between profitability, leverage, corporate governance, value of the firm? Do you see a connect between them or not?
Yes, sir.
Why something is causing that relation? What is that which is causing this relation? Shalini?
Yes, sir.
What is that which is causing the relationship between them? Will you say leverage is impact to the profitability, or what? Profitability is impacting leverage, or there is something at the back which is working?
They are related, sir. Because if a firm takes leverage, firm gives interest for that. So when they give interest, so definitely profitability of the firm is reduced because of that. So they are interrelated in this terms.
Interrelated. What is that which is causing this interrelationship between them? Do you have some factor? Impacting relationship.
Tax advantage.
Tax advantage.
Tax advantage.
Yes, Indrajit.
The size of the firm also affects this.
Okay.
I mean, various other factors.
Suppose if I take size, what does it mean? There is an underlying factor which may be size of a company.
Yes, sir.
What is impacting? What is happening? Size of a company is impacting your profitability, impacting your leverage, impacting your corporate governance, impacting your value. And that's why you see the correlation between them.
Yes, sir.
So it is the size of the company which is your underlying factor causing this relationship. How to analyze this? This is your dependent variable. 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 And this is your independent variable. You know, what is important is the relationship which we are seeing between the financial variables. That relationship may be because of some other underlying factor, which we may not be able to see. And as a researcher, we have to find. Size is one of the factors. Okay, what else? Ownership structure may be another underlying factor.
Yes, sir.
But how do we model such kind of problem? Anybody else? Let's take another example, not from finance, but from other area. Many times we saw that there is a relation between motivation level and the stress level. Why they are correlated? What is that which is working at the back of it, creating the relation between these two?
Team leader.
Hello?
Team leader or their boss.
That means leadership style, right?
Yes, sir.
There may be other factor, but let me take leadership style. So what does it mean? The leadership underlying factor may be your leadership style. And this leadership style may be impacting your stress level, your motivation level. Just a minute. Give me a minute. Many times you will see there are problems, which is, sorry. where we are studying the relationship between the variables, and there may be a number of dependent variables, and we find they are correlated. And they are correlated because there may be some underlying factor at the back of it. In that case, what should we do? That's important thing. Anybody else? Any other example? Maybe from marketing you can give. इंद्रजीत कोई फाइनेंस का एग्जांपल दो.
Sir, in marketing, can it be impact of advertising on sales?
No. Give me some independent variables which are impacting which is impacted by some underlying factor. Indrajit?
Yes, sir.
Looking for an example.
Sir, I was thinking कि interest rate, inflation rate और stock मतलब bond prices और stock prices interlinked भी लगते हैं और further depend करते हैं जो मतलब benchmark rate होता है.
So, what does it mean? What does it mean?
So the return in the bond market, return in the equity market, but further they depend upon what is economy's.
So the bond market returns and the stock market return, they may be related with each other, right?
Yes,
so,
sir.
Can I say stock market is impacting bond, or there is some underlying other factor?
So there are underlying other factors also.
But तुम लोग research में क्या कर रहे हो? Shani? What you people are doing?
In terms of इसको मॉडल कैसे करेंगे?
हाँ.
Okay. So अगर मेरा कोई underlying factor है.
But how do we know? How many of you try to understand that underlying factor?
So in terms of cross effects in regression, we check that.
But in regression, you take one dependent variable at a time. But here you may be having a number of independent variables.
So usually multicollinearity कई बार चेक करते हैं पर कई बार नहीं भी करते.
No, it's not a question of multicollinearity.
Okay. but कई बार underlying variables हम लोग ignore कर देते हैं.
I've taken one variable that you may be having other variables which are impacting them. Friends, please try.
Work culture.
Yes, Shefa. So
work culture.
You give me dependent variable which are impacted by work culture.
It can be type of
motivation level can
motivation
get
level.
Yes, performance of the employee.
Performance.
Or self-esteem of the employees.
Stress. Okay. Self-fulfillment. All this may be affected by work culture, right? And they will be correlated among themselves. They may be correlated among themselves.
Yes, sir. Yes, sir.
and they are caused by one underlying factor. How to study it? Change in the text method on revenue of government. Anju, I could not understand what you mean by change in the text method. How to model. Shali, can you imagine? How can we model it? You don't have independent variables, you have a number of dependent variables.
So here we have one independent variable and there are four dependent and one independent variable.
Yes.
Sorry. Yes.
Culture is
text collection method from VAT to GST. And I'm not able to understand what you're trying to say.
So shall we apply multivariate regression analysis over here?
Multiple regression,
Multiple regression, Dr. Maya, requires
multivariate.
Multivariate regression. Multiple nahi.
Okay. In the GTAB, have you seen variables like leverage, corporate governance, profitability, all are impacted by ownership structure?
Yes, sir. Can affect.
Tiwari, tu join क्यों नहीं कर रहा? कोई नहीं तो मैंने तेरे को भेजा तो join करो.
so are we supposed to use multivariate ANOVA in this case?
Yes, Shalini, that's exactly we want to do it. But the question is, if you look at the research papers, ownership structure you will find in every study, whether it's in corporate structure, corporate governance, okay, size, everywhere you will find them.
Right.
And leverage you will find working everywhere. I mean, why this is happening? I mean, we have to think about it.
Right.
Okay.
Right.
And the problem with all this takes us to discussion on multivariate analysis of variance. Okay. But again, it has limitation. The limitation is we have, of course, dependent variables more than one. Okay. So you have dependent variable 1, dependent variable 2, dependent variable 3, dependent variable 4, and all are impacted by independent variable. And that independent variable should be your categorical variable. That's the issue with ANOVA. So if your dependent is your scale level and independent is also scale level, then ANOVA cannot be used. ANOVA can be used when your independent variables are categorical variables. So friends, appreciate what are the circumstances where you can make use of analysis of multivariate analysis of variance. It's an extension.
Sir, categorical variable means qualitative variable.
Independent variable. Are you talking about dependent or independent?
No, sir, categorical independent variable.
Yes, they are qualitative.
Okay, so we will rank, sir. Good.
We will make the categories.
Okay, sir. Okay. Thank you, sir.
We'll use them, say, officer rank 1, officer rank 2, officer rank 3, right? So what I do, I will create categories of officer rank 1 category, 1 sample, category 2, another sample. So you have some number on the basis of which you are making subgroups or you are making samples. Okay. They have multiple dependent variables, and ANOVA main effects and interactions are assessed in a linear combination of dependent variables. Okay, so you know what it does? I define a linear combination, say beta of 1, dependent variable 1, plus beta 2, dependent variable 2, and so on. I get some quantity, let's call it x. Then x will be related with my independent variable. That is what exactly we are doing in ANOVA. MANOVA tests whether there are statistically significant mean differences among groups on a combination of dependent variables. Kindly note, multivariate analysis of variance is simply an ANOVA with several dependent variables. So you have 5 groups or whatever groups you are taking, and you have dependent variables, which of course are correlated among themselves. And we want to check whether the linear combination of these dependent variable is different among different groups. So if we define, Z as a linear function of my dependent variable, then I want to check whether it is different for the small group companies or big group companies. I take 2 dependent variables, leverage and profitability. And you will get some points. And we observe that this is the group for the companies. This is the group of small companies. I take note of it. Shalini, how do we represent the mean of it? These are 2 dependent variables, 1 and 2. It's a linear plane. How can I express this mean? Yes, Dr. Shifa, anybody? Indrajit, how do you show this mean value?
Sir, x1, x2, 2 different means we can express.
This mean is a function of what?
It will be helpful.
The function of D1 and D2? Dependent variable 1 and dependent variable 2?
Yes, sir.
Right.
Yes, sir.
And we are assuming it's a linear function because mean is a linear function. Similarly, you have for the small one. So what do we want to check? You have a linear combination of the big. You have a
same as
for the small. If these two are different, if these two means are different, what does it mean? This big and a small factor is causing difference. And that's what exactly is being done in MANOVA. So we take a linear combination of dependent variables like alpha 1, dependent variable 1 plus alpha 2 we take for big, we take for small, and check whether these means are different or not. Okay. Is any one of you able to figure out this kind of equation? We use this kind of equation in some other tool also. Z. I have intentionally used the word Z. Shali, where we use Z?
Z score for predicting defaults. Right.
So Z score is coming from which technique?
We use discriminant analysis.
Right. So this is just like your discriminant function. Helps you in identifying distinction between small and big. So if you have two values, okay, failure and success, for example, MANOVA and discriminant analysis, they're one and same thing. No difference. Now, please understand what I'm saying. The linear combination of dependent variables significantly different between small and big companies. And that's what you have to check. So mathematically, I can say that your y's, which are your dependent variables, more than one, ratio scale, independent variables, all categorical. And the more factors you take, the more independent variables you take into your model, more complicated your model will be.
Sir, but when we run discriminant analysis, we take default or non-default as dependent, and
right.
we take all other as the independent variable.
Right. So here what you are taking?
We are saying small and big and other determinants.
Right. Right. So other determinants are what? Dependent variable.
Dependent.
So dependent variable, linear combination we take. So we get a linear combination of one group, linear combination of another group. So I am assuming for the time being, the independent variable which I am considering, having only two categories. Then the centroid, the mean, if they are significantly different, what does it mean? That means that underlying factor is having impact.
Right, right.
What is that underlying factor? Sickness of a company, right? Which we are dividing into two: sound companies and sick companies. Whether sickness of a company is having impact on profitability, this, that you can study. That's what it says. I do not know how many of the participants are from finance background. You know, what is happening these days in finance especially? People are using panel data. And if we are using panel data, then analysis of variance cannot be applied. Or MANOVA cannot be applied. MANOVA can be applied only for the cross-sectional data. So one option is that year by year you apply MANOVA and get the result. Aggregate the results over a period of time. Okay, otherwise you have to think something else where you have large number of dependent variables with independent, large number of dependent variables and a large number of independent variables. Please note that in MANOVA, a new dependent variable is created, which I am saying Z, which is a function of my dependent variables y1, y2, y3, and so on. Then we forget about them. We take this Z and see whether this Z is the function of my categorical variable. In that way, I am saying that it's an extension of analysis of variance. In it, a different linear combination of dependent variable is created for each main effect and interaction that maximizes the group differences separately. That means the means which you will be getting, which technically we call them centroid, how significantly different they are, that you can check. So we have dependent variables. We make their linear combination, get a new variable, and then we have independent variable. Can any one of you apply in your area of expertise? Can any one of you give me example where you think you can make use of ANOVA? Shalini, Indrajit, you know why I ask you to join this? Because we haven't seen our finance problem from this perspective.
Right.
But if we started seeing it from this perspective, maybe we get something different.
Right.
Dr. Shefa, what is your background? Vikram?
Sir, accounts and finance.
Account and finances. So I
Yes,
think you
yes,
will be
sir.
able to understand what we are talking about.
Yes, yes, sure, sir.
Okay. Dr. Maya? Vikram? Yes, Shweta.
Sir, in economics, can we take it the dependent variables as government expenditure on education? Then second is government education on health, on infrastructure.
Education, expenditure, health, infrastructure. Okay, let me take 3.
Okay, okay. And the independent variable, we can take the growth of the economy.
No, I'm looking for a categorical variable.
Okay, categorical. All are the categories of public expenditure?
No, these are the scale level variables, na? Expenditures.
Oh, okay. Okay.
Developed and underdeveloped countries.
That you can take, or you can also take state and center.
Yes, state and center.
For poor and rich countries, sir.
That can also be taken. That's limitation of MANOVA, you can say. So now I think if you have complicated problems where you have number of dependent variables which are correlated with each other, okay, expenditure on education, health, infrastructure, they may be somewhat related with each other. So there's a possibility of correlation between them. But we have to look for a categorical variable which is impacting them. And that may be the kind of the political system we have in our country that can also impact it. Okay.
So we have shortage of resources. So if government makes expenditure in education sector, then he won't be able to make the same expenditure in health sector. So if the expenditure in education sector is higher, then it has to be low in health sector. That's why it is related. We can say that, if
yes,
I'm not wrong.
We can.
Oh, okay. Thank you.
Positive, negative. We say linear combination, right? So alpha education, right? Or let me take beta 1 education, beta 2 health. It's a linear combination, right? So betas can be positive, betas can be negative. So I'm not saying they should always be positive. So let's see what assumptions we are making. Independent variable is categorical. And that's many times restrict us to use MANOVA. Dependent variables should be measured at the scale level or interval, ratio scale level or interval scale level. And multivariate distribution is approximately normal. Multivariate distribution of my dependent variable should be normal. Linear relationship among the dependent variables. Distributions have equal variances, homogeneity of intercorrelations. What are the prerequisites which we need for MANOVA? First, dependent variables should be highly correlated among themselves. How do we check it? Bartlett's test of sphericity can be used to check correlation between the dependent variables. Any one of you recall where we use it?
Factor analysis.
What is the purpose? To check again different items which are using for factor analysis. Are they having correlations or not?
Or not? High correlation.
High correlations or not. So same thing can be used here. Second, equality of the variances. How do we check it? Recall Levin's test of equality of variance. And how can we test overall results of MANOVA? Here we don't use F, we use something similar to it. We have what is called Pillai's trace method, Wilkes lambda method, Woodling trace, Royce-Larcher's root. Normally you will find in literature, people are using Wilkes lambda, capital. Normally all give the same result, but Wilkes lambda is widely used. And Wilkes lambda tests if there are differences between group means for a particular linear combination of dependent variables. And grouping is being done on the basis of independent, categorical, it is similar to your F-test in ANOVA. Wilkes lambda divide the determinant in terms of matrix of within group matrix by the sum of the determinants of within group and between the group. Within, this is within and between. Its maths is highly complicated. Okay. Before I take some numerical on it, I want to know from you what feel we get about analysis of multivariate analysis of variance. What exactly it does, where we can use, what kind of data we need. Yes, Shweta.
Yes, sir. When there is one independent variable, which is categorical variable, and
Shweta, just hold. I have taken one independent variable as an example, but you can have a number of independent variables.
Okay.
All of them should be categorical.
Okay, sir.
I've taken one for illustrative purposes to make the thing simple, but you can have more than one independent. But
Okay, sir. Okay.
Dependent must be necessarily more than one. If it is one, then you can make use of an ANOVA.
Yes, sir. Yes, sir.
For one dependent variable. Multivariate of analysis more than one dependent variable. Yes, Shweta, please go ahead.
Right. So what I have understood is when we have multiple variables and we have all the dependent variables are also correlated with each other.
Multiple dependent variable, right?
Yes, sir.
And they are
correlated.
If they are correlated, what does it mean? You can have a linear relationship between them?
Yes, sir.
And they're all scale level, so linear mathematics can be defined on them, linear structure can be defined on them.
Yes, sir.
A new variable, let's call it Z. And then for each individual, we see whether this Z is same or different.
Right, sir.
Okay. Anybody
yes,
else?
Sir.
Anybody else?
Clear, sir.
Friends, please don't hesitate.
Sir, one simple question, sir.
Sanjay
The
ji.
name is analysis of variance, but for here, just you have taken example of checking mean of that large and small company. So, sir, so variance just is one assumption, but analysis of variance, how means what is the purpose of this nomenclature, sir?
Okay. X affecting Y. Y is my scale level data. This is my categorical data. This is ANOVA. Okay. Then I have X impacting Y1, Y2, Y3. All the variables, all Y's are scale level dependent variable. X is my independent variable, which is categorical variable. Now, Sanjay, you can appreciate the difference. ANOVA, we take one dependent variable. In multivariate analysis of variance, we take multiple dependent variables. That's how we see the difference.
Yes, sir, clear.
Anybody
Sir,
else?
Sir, I have a question.
Yes, Simran, please.
Sir, either in ANOVA or MANOVA, either in ANOVA or MANOVA, if there are two independent variables, one is on nominal scale binary and another independent variable is on ordinal scale. Still, we can ordinal measurement. So still we can run ANOVA and MANOVA with one binary and one ordinal.
Doesn't matter. X1 and categories, say big and small. Okay.
Yes.
Another category may be ownership structure, public, private, foreign. 3 categories, possible, no problem.
And sir, when we check the in MANOVA, the assumption is same equality of variance and normality. So we check this for the Z score that has been obtained from dependent variables, or we check normality and for all the dependent variables?
Not for check, all we take variables together and check, because it's a joint joint distribution, not individual. Jointly, they should be normally distributed.
Jointly, but sir, when we run scarce test, it gives us 3 different rows for Y1, for Y2, for Y3, p-value.
We have to use multivariate normality test, and I don't know where it is available in SPSS. I have to search for it.
Okay, sir. Thank you, sir.
Okay. Anybody else? Please take time, meditate, and think. Have you really understood MANOVA karta kya hai?
Sir, Sandra Almeida from Bombay.
Yes. Yes, go ahead.
So I just got this much that if we have one independent variable and maybe 3 dependent variable, then if we apply ANOVA, the limitation is that we can take only one dependent variable at a time. But ANOVA tries to give the solution because we can apply the test like multiple dependent variables at a time. That's what I got from this.
Okay. Sandra, I have a question for you.
Yes, sir.
I have 3 dependent variable, D1, D2, D3, right? 1 independent variable.
Yes, sir.
So what I do is I run ANOVA here. I run ANOVA here. I run ANOVA here. I don't process them simultaneously. I run 3 different ANOVAs. What's the problem I'm facing? Shalini, tell me. If you have 3 ANOVAs instead of 1, what's the problem you face? Indrajit?
May I? Sir, it will not take care of the underlying commonality.
Indrajit?
Ji, sir.
Think again. Anybody else?
Are we decreasing the degree of freedom?
The correlation, the dependent variable, when they are correlated,
let
make
me
a
ask,
different result.
Let me ask you a simple question. I have 3 groups, right? So what I do, group 1, 2, 3, I apply a t-test between 1 and 2, t-test between 1 and 3, t-test between 2 and 3. So why I'm using ANOVA then? I can apply 3 t-tests. Charlie, now you give me the answer. Why ANOVA? Why not 3 t-tests? Where you see the impact? Indrajit, where do you see the impact? Type 1 error.
Yes, sir.
Because if you take up level of significance, say 10%, right? So not committing type 1 error is 90%. First case.
And again, it is
third case.
Cumulating.
9. We get 0.729. That means your alpha becomes, type 1 error becomes 172. Sender, you know what happens? If you perform ANOVA separately, your type 1 error increases like anything. So instead of doing it in different goes, we let it go once. That's one important statistical reasoning. And of course, as you people are saying that commonality, relationship, correlations among the variable, which provides us rich information, we will also be losing that information. Yes, Asha, Jacob, error multiplication. Absolutely right, Asha. Senders, I think you got answer to your query, or still you have something different in your mind?
Yes, sir. Thank you, sir.
Okay. So let's take case 1, and a researcher wants to know whether the leadership style adopted has any impact on the stress level and motivation level. And this is the model they are using, and they have identified 3 leadership style: laissez-faire style, participative, autocratic. And they want to study and if you see here, motivation level and the stress level, see here, one group. Another group. That means leadership style is impacting the motivation level and stress level. Say autocratic style of leadership. The stress level is high. Motivation level is comparatively low. Laissez-faire and this participative is having less stress and high motivation level. Laissez-faire, less stress but less motivation. So graph tells you something which you can appreciate. So let's, what are the hypotheses which we have to test in MANOVA? That means the mean of this is stress of laissez-faire, stress participative, stress autocratic. Motivation level under laissez-faire, motivation level under the participative style, motivation level under. So are they equal? Or they are not equal? That's what we are checking. So if the stress level differ across style, motivation level differ. We're not testing them separately, we are testing them jointly. And at least two of these groups are not same, are different. Okay. So let me open up a file. Sorry. So I have two dependent variables, stress and motivation, style. And another thing you have to understand. Indrajit, ANOVA, MANOVA. Are they using linear models or non-linear models?
Sir, linear model.
Linear models.
Linear model.
Yes, ANOVA and MANOVA, they are using linear models. So in SPSS, we have to search for generalized linear models. So go to Analyze, Generalized Linear Models, General Linear Models, Multivariate. My dependent variables are stress level and motivation level. Leadership style is my fixed factor. And we have a full factorial model. Plots, you can have a horizontal here. If you want separate lines, separate lines for this style, you can have it. Postdoc, okay. Options. Okay, options we will take later. I think it's repeated measures. We take it as covariate. Okay. If I see here, Wilkes lambda, it's less than 5%. So my null hypothesis that the mean across categories among dependent variables same is rejected. Okay, where we have the impact, I can see, sorry, this is for intercept and this is for style. For style also, this is coming to be significant. If you remember, I said it's a linear combination with intercept. So intercept is coming to be significant and the coefficient of the style is also coming to be significant. Then, what is the impact of the stress style on the stress level? It says style is having impact on the stress level, but style has no significant impact on motivation level. That's what it is. Style is not impacting the motivation level, but style of the leadership has an impact on the stress level. And you can see the graphs. Okay, so I do it again. Plots. I'm just closing it. There is some issue in my latest versions. I'm using the oldest version to show you how do we do that. This is my data. You can see the analyze, general linear model, multivariate. Stress and motivation level is my dependent variable. Leadership style is my fixed. Plots, style, horizontal. Sorry. Okay. And post talk.
सर ये लीडरशिप स्टाइल कोवेरिएट्स में जाना चाहिए?
नहीं, कोवेरिएट्स में वो स्केल लेवल डेटा लेता है. तिवारी जी, गुड मॉर्निंग.
नमस्ते सर.
Leadership motivation level and stress level, and this is giving me right results. I don't know, there was some problem with the latest version. Maybe I'm not that comfortable with the latest version. If you see here, this stress level, style stress level, significant. Style motivation level is significant. And R square is A is what? Okay. For stress level, the R square is so much. And for the motivation level, my R square is so much. So that means style explain stress level much more than the motivation level. That you can also find out from here. Both are impacting my, leadership style is impacting both my stress level and my, if you see the graph, laissez-faire, the stress is minimum, autocratic stress is maximum. Motivation level, autocratic, motivation level is minimum, participative motivation level is highest, laissez-faire, the motivation level is not much. And we also have a pairwise comparison here. Stress level, laissez-faire, sorry. Comparing with participative style, autocratic style. And yes, this is significant. The stress level between participative and autocratic is different. Autocratic is different from laissez-faire and leadership. Same you can study for the motivation level. Let me take another example. A researcher wants to know whether the increase in perceived value of a product and customer loyalty depends on marketing style adopted by a marketer and the background of the customer. So now here you will find there are two independent variables and two dependent variables. So customer background, which is rural and urban, marketing style, which is social marketing, augmented marketing, direct marketing, relationship marketing, service marketing, and their impact on increase in perceived value and the customer loyalty. And here you can make use of, analysis of, MANOVA. So I take you back, open that file. So we have the style, we have the value, we have the loyalty, we have the background. I go to analyze, general linear model, multivariate. Dependent variables are my increase, perceived value, and the customer loyalty. And fixed factors are my marketing style and the background. सलोनी अन्नू को मना करो, एनोटेशन पे वो कर रही है.
हाँ जी सर.
Then plot style horizontal. And background. And post hoc or style and background both. Sorry. In this case, you will find all statistics are coming to be significant except background. That means style is having impact, background is not having impact. The style and background interaction is having impact. And this is the style, significant, background, not significant, but interaction is having significant impact. What is interaction? Maybe I think I should show you through graphs. I show you what interaction means. This is urban, this is rural. See, direct marketing has higher impact on rural background customers. Social marketing is having higher impact on urban. Service marketing, highest. So there is interaction, means in some cases, some marketing style is impact on the rural. In some cases, the marketing style is having more impact on the urban. In that sense, we say interaction. Whenever you see interaction effect, these lines will cross. If I show the other graph, rural, high, low, high. So social marketing, the urban people show higher customer loyalty as compared to the rural people. But as far as the augmented marketing is concerned, the rural people are showing more effect. Okay. Similarly, relationship marketing, urban people are showing more effect. So I cannot generalize that, the background will always give higher customer loyalty. For some cases, it gives higher, some cases it gives lower. In that sense, we say interaction between the variables. So you can see the interaction, you can see individually. I mean, one thing you will appreciate, power of this particular, how powerful MANOVA is. Not only it gives you individual effect, it also gives you interaction effect. Not only give you one dependent variable impact, it also gives you a number of dependent variables effect that you can do. So friend, that's all I want to discuss in MANOVA. If you still have a question, and the output which is coming out of the MANOVA result, it's highly complicated. So it will take some time for you to comprehend this particular output. So
Thank you, sir.
Anjali is saying that's enough for the day. Yes, I understand that's enough for the day. What is the role of R square and adjusted R square in the interpretation? Sharmila, R square is not adjusted for degrees of freedom. Why adjusted R square is adjusted for degrees of freedom. So if you are comparing models 1, model 2, model 3, there use adjusted R square for comparison purposes, not R square. But to get an idea how much variation is being explained within a model, for that you have to use R square. So that's the difference between R square and adjusted R square. Sharmila, is that clear or still you have a doubt? Yes, anybody? I think in between somebody was trying to ask something. I don't know who was that. If UVs are not correlated, then which tool is apt? Okay, so if dependent variables are not correlated, doesn't matter. You can make use of individual ANOVA. That you can do. Individually, you check dependent variable by making use of analysis of variables. Okay, anybody else? No, so that's all from my side. Thank you very much and enjoy. Have a good time. All the best to all of you.
Thank you so much on behalf of TLC Ramanujan College and Indian Accounting Association. I would like to take the honor of delivering the vote of thanks for this session. Sir, I would really express my heartfelt gratitude to you for such an enriching session, and thank you, sir, on behalf of all the participants.
Thanks.
I would like to say that you have answered each and every query of every possible person here, and that's really great of you, sir. Thank you so much.
Thank you. Thank you, Saloni, and thanks everyone. We'll meet again, okay, with the different topic.
Yes, thank you so much.
Thank you, Samir.
All participants are requested to fill the feedback form as well as the quiz for today's session, and all updates regarding tomorrow and day after will be sent on your Telegram group. Thank you.
Hello. Thank you, Saloni ma'am.
Yes, ma'am.
Ma'am, Sandra Almeida here from Mumbai. Ma'am, as if now we have to do 2 assignments. Yesterday's assignment by today, and today's assignment we can do it by tomorrow. And
yes,
sorry, this quiz. So only 2 quiz are there right now. Yeah, because there was some problem with my password, so I got entry this morning.
Yes, ma'am, you can fill it. No worries. If there's any problem, you can contact any.